Previously, we explored a one-dimensional analogy to consolidation. Now, let's see how to analyze actual consolidation test data. In the oedometer setup you see here, the soil specimen is subjected to loading, and the resulting settlements are recorded using a dial gauge. After obtaining the dial gauge readings from the consolidation test, the readings are plotted against the square root of time. The initial straight portion of the curve represents the early stage of consolidation. A line is drawn along this segment to define its slope. Another line with a slope equal to the original slope divided by 1.15 is then drawn. The point where this new line intersects the curve corresponds to T90, representing the time for 90% consolidation. The T90 value obtained is used in the equation to calculate the coefficient of consolidation, CV. Since the specimen allows double drainage, the drainage path length is taken as half of the average specimen height for that load increment. In this case, the calculated CV is 0.0384 mm² per second. In contrast to Taylor's square root of time method, the Casagrande method uses a plot of dial gauge readings against the logarithm of time. The curve typically shows three distinct portions: initial, primary, and secondary consolidation. The point of intersection between the lines drawn through the linear portion of primary consolidation and the secondary compression region gives T100. To determine T0, the difference in dial gauge readings at time T1 and 4 times T1 is calculated and added to the initial reading. The average of the dial gauge readings at T0 and T100 gives the dial gauge reading at T50. Using the T50 value obtained from the Casagrande method, the coefficient of consolidation, CV, is calculated as 0.0328 mm² per second. Let's move on to something interesting, a special topic in consolidation. In soft clays, Terzaghi's theory doesn't always hold true. It assumes Darcy's law, meaning water flows at any gradient. But real clays behave differently. Below a critical gradient, flow stops completely. That's where Hansbo's non-Darcian model comes in, showing how consolidation slows down. And settlements can continue for years. Terzaghi gives the ideal, Hansbo shows the reality.